So in this video, I try to explain how to formulate the minicase 6 roster planning. So roster planning basically is also multiple period work scheduling problem. So we start with understanding this problem or parameter first. This problem deals with roster planning in a big company in a production facility work days, Monday to Friday. A certain number of employees are needed each day in order to handle the production. In the table 6, you can see the employees needed during the work days for each shift. So the work basically consists of 2 shifts. First shift is in midnight to 12, and the second shift is from 12 to 24. Furthermore, a number of union rules need to be obeyed by. There are 3 rules listed as ABC in the text. The rule A, so an employee is on duty either from midnight to 12 or from 12 to 24. And the works the same shift each day of the week. An employee can start his or her duty on any given workday. An employee follows a schedule and is on duty for 4 consecutive days. So these are the basic rules, and the question 1 asks you to formulate an LP model which minimizes the total number of employees during the 3 modeling steps. Assume that the schedule is cyclic. Table 7 holds for all weeks, and moreover, the model needs to respect the union rules, as well as the required number of employees on duty each day. So first, let's see how should we define the decision variables. We could actually define one single variable with 2 indexes. For example, you define x, I, g, and the I can denote the shift, and the g can denote the weekday in each week. For example, Monday, Tuesday, Wednesday. However, I think as a beginner in this course, we try to make it more clear. So we assume only one decision variable. So I just remove this single decision variable method. So we first let x, I be the workers for each day at morning shift. Here we know I equals to 1, 2, 3, 5, and then we also let y, I be the workers, number of workers for each day at afternoon shifts. So if we see this as define decision variables, and then we have a second step to formulate the objective function. So as you noticed in the question 1, they actually ask to minimize the total number of employees. So we actually need to minimize, for example, minimize total number of employees across different days in 1 week, and for both morning shift and afternoon shift. So that's an objective function. And the third, we try to formulate constraints. So the constraints actually is a series of constraints. For example, we actually need to minimize the, or we needed to satisfy minimize the employee requirement for each day, which is defined in the table 7. So here you can see in the morning shift, Monday, they need at least 900 employees. So we can just calculate the workers work on Monday morning shifts. So the idea is now you know this is only about morning shifts. So you only consider the X variable. So we just calculate the different days which work on Monday, because here it actually said the employees can start at any work day and then they only work for 4 consecutive days. So you have to think about the workers. So I can just simply draw a timeline. So this is Monday, Tuesday, Wednesday, Thursday, Fridays. It's not sorry, Tuesday, Wednesday, and Thursday, and Friday. And if the worker start from Monday, of course, then you need to calculate X1, and then the worker can work Tuesday, Wednesday, and Thursday for 4 consecutive days. If a worker start to work from Tuesday, then this worker also actually work 4 days. Then only work, so you only work Tuesday, Wednesday, Thursday, and Friday. So this worker actually not work on Monday. So we do not actually include the Tuesday started workers. And if the work started to work from Wednesday, then you need to see, okay, they work from Wednesday, Thursday, Friday, and Monday. So in that way, you can go through the entire linear time network. Then we just put x1 plus x, probably use blue, plus x3 plus x4 plus x5 should actually greater than or equals to 900. So this is how you formulate the constraints to calculate the total number of workers work on Monday morning shift. Then we take next example for the Tuesday workers morning shift. So how many workers actually work on the Tuesday mornings? So this includes the workers work start from Monday, Tuesday, Thursday, and Friday. So they will not include the work from Wednesday, because if a worker started to work from Wednesday, then they will actually only work 4 days, will not work on Tuesday. Then we can just write, okay, next constraints. So Monday started worker plus Tuesday started worker plus Thursday and Friday. So this should be greater than, just cross it, 1000. We have to actually check all the 10 varieties. So morning shift, afternoon shift, and Monday until Friday. So you should actually have 5 constraints for the morning shift. So for example, for the Friday workers, then you should know if the worker started to work from Monday, then will never work on a Friday. So you can actually make the 5th constraint is x5 plus x2 plus x3 plus x4 should be greater than 700. So that's only morning shift. If we see it's this morning shift, and then we can actually do the similar way for the afternoon shift. You should also have 5 constants regarding your user green. So regarding your decision variable y, then we actually should have the similar y1 plus y3 plus y4 plus y5 greater than equals to 800. So here is 800 for the Monday number of workers. Similarly, you can write y5 plus y2 plus y3, y4 greater than equals 750. So when you actually see the guided solutions in the Excel or in the PDF file, you may see the different format of the formulations, but actually they mean the same thing, or they are equivalent formulations. And then in the end, do not forget the non-negativity. I'll just write it. Non-negativity constraints. So that's how you actually formulate this roster planning problem. So this video just help you to understand why this is the formulation is actually formulated. If you have any questions, you can ask the lecturer. Otherwise, you can also look into the Excel solutions with the formulations, all the explanations in the PDF file.